So in this video we're going to continue with CC2, which is separating mixtures, and we're going to look at a different technique called distillation. So distillation can be used to separate a soluble solid from a liquid. And if you watched the first video I made on this topic, you might be thinking, well, that's exactly the same as crystallization. We came across crystallization in the last video. And we saw that if you have a soluble solid, which is a solid that has dissolved in a liquid, and you want to separate that solid from the liquid, that you use crystallization. You heat the liquid, that will cause the liquid to evaporate, and you are left with the salt. The problem with this method, though, is that the liquid evaporates. So you evaporate that liquid, and you form a gas, and that gas escapes. So if you had water as your liquid, you would turn it into water vapor, and then that vapor will just dissipate around the room and it will escape. What happens though if you wanted to keep the liquid? Okay, what happens if it was the liquid was what you were interested in? You wouldn't want that liquid to just escape. You would want to have the liquid at the end of the experiment, and with crystallization, you don't. If you want to actually keep that liquid, then you use a different method. You use distillation. So the process is similar. You're going to start off though with what we call a round-bottomed flask instead of an evaporating dish. And into my round-bottomed flask, I'm going to put salt and water. And I do still need to separate the salt from the water, and I am still going to be using the process of evaporation. So I'm going to be heating my round-bottomed flask. And again, just like above, what's going to happen is that your water is going to evaporate. So I'm just going to draw a little line here to show that the water evaporates. And when it evaporates and from a gas, the hot gas will rise. So water evaporates and the gas will rise. Okay, this is all the same as crystallization so far, and in crystallization, once that hot gas rose up, it just escaped. What we want in this case is we don't want that hot gas to be able to escape. We want to be able to trap that hot gas. And not only do we want to be able to trap it, but we want to be able to go from a gas back to a liquid. So that's what we're going to do in distillation. So my drawing skills aren't the best. We're going to have something that looks like this. Okay, so rather than having, I'm going to put a thermometer in here. Okay, rather than having just an open container where all the gas can escape, we are going to trap that hot gas. And what we're going to do is we're going to cool it back down so that it becomes a liquid again. To cool a gas back to a liquid, that is called condensing. And we use a condenser in order to do it. So the condenser is just, I'm going to draw it as like this tube. And you need the condenser to be really, really cold. If it's not cold, then this isn't going to work. So what you've got flowing around your condenser is you connect your condenser to the tap and you have cold water flowing around your condenser. You've got water going in at the bottom and that water comes out at the top. Now this tap water is purely to keep your condenser cold. The water from the tap does not mix with the water from your experiment. So if I track what's happening with the water here, I'm going to use pink. Okay, so these are the water vapor. It's rising up, rising, rising, rising. It hits the condenser and it cools down, and then that water is going to move along the condenser and it's going to be collected in a conical flask. And it's going to be collected here in the conical flask. The water coming from the tap, which I'm going to draw in, give me a different colour, yellow. The water that comes in from the tap is purely just to keep the condenser cold, but it doesn't mix with the water from your experiment. It just keeps your condenser cold, so you get efficient state change from the gas back to a liquid. A few things to point out on this diagram. You're not going to be asked to draw this diagram, but just a few things to point out, okay? You have to seal the container at the top, okay? If you don't seal it at the top, this hot vapor will just rise and it will escape just as it did in crystallization. So you're going to seal it at the top. This here is a thermometer because I want to see at what temperature my gas is condensing. Okay, and we'll come back to why in a second, but I've got a thermometer here, and the thermometer shouldn't be the whole way down in your round bottom flask. It should be just here, level with the condenser. With the condenser itself, the water goes in at the bottom and it goes out at the top. And the reason is that if you put the water in at the bottom, it has to kind of go against gravity. This is actually been a bit more of an angle, but it has to go against gravity and it fills slowly from the bottom, but it means that the whole condenser ends up full. If you put the water in at the top, what will happen is it will just fall to the bottom of the condenser and flow out, and this top part of the condenser will remain empty. You need water on both sides of the condenser, so you always fill from the bottom, and then you collect your water here in your flask. The salt, really high melting point, so it's going to stay in your round bottom flask. So at the end you've got the salt in your round bottom flask, you've got the water here in your conical flask. So the advantage over crystallization is in crystallization, yes, you're left with your salt, but you've lost all your water. In distillation, you end up with both. So if we look at some typical questions that occurs, okay, they can ask you about the state changes that occur in distillation. So your first state change is going to be evaporation. And then after you've evaporated the water, you then condense it. So you've got two state changes. You're going from liquid to gas and then from gas back to liquid. So evaporation first and then condensation. The benefit, you collect your solvent. You don't lose it like you do in crystallization. Why does your cooling water enter from the bottom and leave from the top? Because it must enter from the bottom so that the entire condenser fills. If it enters from the top, it won't fill the entire condenser. It will just fill the bottom half of the condenser. That's a really common question. They can ask you to label the distillation apparatus. You need to know that you put the water in at the bottom and it comes out at the top, so that the entire condenser fills. And then, how could you use simple distillation to purify seawater? So if you wanted to purify seawater, you need to remove the salt from the water so that you can drink it. If you want it to be left with drinking water, then you don't want that water to all escape, which is why distillation would be perfect. So you put your seawater in your round bottom flask, and you attach the condenser. Remember, you don't want that water vapor to escape. You attach your condenser, you heat, don't just say evaporate, okay? Mention how. You're going to heat, that's going to cause the water to evaporate, the hot vapor will rise, it will hit the cold condenser, it will cool, condense, and you can collect it as a liquid in a conical flask. What happens to the salt? Well, it's got a really high melting point, so it's not even going to melt with the heat that you are applying. It's just going to stay as a solid in your round bottom flask, and that allows you to separate the salt and the water. Okay, if we look here at an exam question on it, so you have got the apparatus for distillation and you're using it to separate water from a solution of ink. So you can also use distillation to separate two liquids that have different boiling points. The first question asks you for the apparatus used to heat the round bottom flask. You could say a hot plate, a Bunsen burner, a heating mantle, anything that's used for heating. Then I want you to label apparatus A. Apparatus A is your condenser. And you can see this time they've labelled it for you, in at the bottom, out at the top, but they could also ask you to label that. So it's called a condenser. State the temperature reading on the thermometer when the pure water is collecting. So you can see here, this is where your thermometer is, and it's at the point where your water is starting to condense. So if you give a temperature of 100 degrees Celsius, because that is the boiling point of water, so it's here at that state change. The hot vapor is rising and then it's cooling. So it's right at the point where the state change is occurring, and that state change between liquid and gas to water is 100 degrees Celsius. The rest of that question is about chromatography, so we'll come back to it in the next video. Okay, so in that exam question, I mentioned that you could use distillation to separate two different liquids. So we're going to have a closer look at that now. So I've drawn out my distillation apparatus again. This is actually better than the one I drew a second ago. It should be at a kind of a vertical sorry, it should be at a slant. It shouldn't be perfectly horizontal. It should be at a bit of a slant. So this is my distillation apparatus again. You could be asked to label which way the water goes in and which way it goes out. So remember, it goes in at the bottom, water is going in, and it's coming out at the top. Remember, that's just the water from the tap. It's not actually mixing with our experiments at all. It just keeps your condenser cold. And here in my round bottom flask, I've got water and I've got alcohol. So they're two different liquids. They mix together. We want to be able to separate them. Water and alcohol have different boiling points. Water boils at 100 degrees Celsius. Alcohol will boil at 78 degrees Celsius. If I heat my round bottomed flask to 78 degrees Celsius, then what will happen is the alcohol will be turned into a gas. The alcohol will evaporate, but as long as I don't hit 100 degrees Celsius, my water will remain as a liquid. This is when the thermometer becomes really, really important. You need to track the temperature. So I heat it to 78 degrees Celsius. The alcohol will evaporate, the hot air will rise, it will hit the cool condenser, and your alcohol will collect here in your flask. As long as you're not heating this mixture above 100 degrees Celsius, then the water will remain as a liquid in your round bottom flask. And at the end of the experiment, you'll have water in your round bottom flask, you'll have alcohol in your conical flask. So if you've got liquids that are mixed together and they've got different boiling points, you can also use simple distillation to separate them. There's another form of distillation called fractional distillation, which you cover in detail in CC16. So this principle is seen in CC16. You've got crude oil, which contains lots of different fractions, and you heat the crude oil, and because your fractions have different boiling points, you can separate them using fractional distillation. So it's the same as what I've just gone through, except you've got lots of different fractions, so you've got slightly more complicated apparatus, but the principle is the same. You heat it, it becomes a gas, the hot vapors rise, then they cool and condense and become liquids again. And the reason you can separate these liquids is because they all have different boiling points. It wouldn't work if they have the same boiling points. Because they've got different boiling points, you can separate them using distillation. So final use for distillation, you can actually use distillation to separate out the gases in air. So if we think of the gases that we've got in our atmosphere, we've got nitrogen, you've got oxygen, you've got carbon dioxide, and again, these are all gases. If you wanted to separate out these gases, you can use distillation. Now, as I said, we're using distillation to separate liquids, okay? So what I would need to do is I would need to take those gases, I would need to cool them, and I would need to condense them so that I'm forming liquid versions of each of those gases. Once I've got liquid versions of those gases, then I can use my fractional distillation. They all have different boiling points, so I can use fractional distillation to separate them. So that's another common exam question. How do I separate the different gases in the atmosphere? You cool them and condense them to make them liquids. They are liquids with different boiling points. Because they've got different boiling points, you can use distillation. So more specifically, it's fractional distillation, but just saying distillation will get you your mark. And that's pretty much it for distillation.